On February 28, 2025, POLARIS Spaceplanes, a German aerospace startup founded in 2019, announced it had secured a pivotal contract from Germany's Federal Office of Bundeswehr Equipment Information Technology and In-Service Support BAAINBw. This contract involves the design of a reusable hypersonic research vehicle, marking a significant advancement in Germany's aerospace and defense capabilities. Background of POLARIS Spaceplanes. POLARIS was established as a spin-off from the German Aerospace Center DLR with the goal of innovating in the aerospace sector. The startup has focused on developing the AURORA, a multipurpose spaceplane and hypersonic transport system. Over the years, POLARIS has tested various prototypes, notably the MIRA series, which includes MIRA 2 and MIRA 3. These 5-meter-long vehicles have collectively completed over 100 successful test flights, showcasing the company's commitment to advancing aerospace technology. The MIRA series utilizes a linear aerospike rocket engine. This technology, which has faced engineering challenges historically, is now seeing new advancements through POLARIS's innovative approaches. The successful development and testing of the AS-1 aerospike engine, which recently achieved in-flight ignition, underscore POLARIS's technical expertise and readiness for more ambitious projects. Contract details. The newly awarded contract is focused on designing a 2-stage fully reusable spaceplane intended to be approximately 28 meters long. This vehicle will serve as a testbed for hypersonic flight research and defense applications, while also having the capacity to act as a small satellite launcher when fitted with an expendable upper stage. The goal is for the Hypersonic Research Vehicle to achieve speeds exceeding Mach 5, which corresponds to over 6,125 km per hour. This capability positions the vehicle as a potentially cost-effective alternative to conventional rocket launches, given its ability to take off from standard runways and be reused multiple times. Initially, the contract centers on the design phase. However, it includes provisions for future initiatives that may extend to manufacturing and flight testing the full-scale vehicle. This multi-phase approach indicates a long-term commitment to advancing hypersonic technology and its applications. Strategic importance. The development of the AURORA and its hypersonic research vehicle is part of a broader strategy to enhance Germany's defense capabilities. This effort comes amid increasing calls for military modernization in response to rising geopolitical tensions in Europe. The German government has emphasized the need for greater investment in defense technologies, and POLARIS's contract aligns with these national priorities. Technological innovations. The AURORA project builds upon decades of research in spaceplane technology, integrating advanced propulsion systems and reusable design features. The aerospike engine technology in particular represents a significant leap forward. Aerospike engines are known for their efficiency at varying altitudes, allowing for improved performance in spaceflight. POLARIS's advancements in cooling technologies and materials are critical to overcoming previous engineering obstacles associated with aerospike engines. The successful ignition of the AS-1 engine during tests signifies a milestone in POLARIS's development journey. The engine produced thrust while being integrated into the MIRA 2 demonstrator, paving the way for further testing and refinement. Future prospects. As POLARIS Spaceplanes embarks on this ambitious project, the implications for both the aerospace industry and the defense sector are substantial. The vehicle's dual role as a hypersonic testbed and a small satellite launcher could revolutionize how payloads are delivered into low Earth orbit, making space access more affordable and efficient. Moreover, the potential for the Hypersonic Research Vehicle to support defense-related research underscores its significance in enhancing national security measures. The ability to conduct experiments in high-speed flight and aerodynamics will not only benefit military applications but also contribute to scientific and institutional research. Conclusion. In conclusion, POLARIS Spaceplanes is poised to play a crucial role in the evolution of German aerospace capabilities through its innovative designs and advanced technologies. The contract with BAAINBw represents a key step in this journey, with the AURORA spaceplane set to redefine the landscape of hypersonic flight and space access. As Polaris moves forward, it will undoubtedly contribute to the broader goals of enhancing defense capabilities and fostering innovation within the aerospace sector. Positioning itself as a vital player in Europe's aerospace engineering landscape. The recent announcement regarding Polaris Spaceplanes' contract with Germany's Defense Procurement Agency reveals several counterintuitive aspects of the aerospace and defense industry, particularly in the context of reusable hypersonic vehicles and their applications. 1. Reusable space systems versus traditional rockets. At first glance, the development of a reusable hypersonic spaceplane like Polaris's AURORA might seem redundant in the realm of established rocket technology. However, the counterintuitive realization is that these spaceplanes could potentially offer a more cost-effective and flexible solution for launching payloads into space. Unlike traditional rockets, which require extensive infrastructure for launch and recovery, spaceplanes can take off and land on conventional runways. This could drastically reduce the overall costs and logistical challenges associated with satellite launches. 2. Military applications of a spaceplane. The idea of a hypersonic vehicle primarily designed for defense applications might seem focused solely on military capabilities. However, Polaris's AURORA is also positioned as a platform for scientific research and experimentation in high-speed flight. This dual-use nature challenges the conventional understanding that military technology is strictly for combat or defense, illustrating a broader spectrum where cutting-edge technology serves both military and civilian purposes. The vehicle's ability to function as a small satellite launcher when equipped with an expendable upper stage further underscores this versatility. 3. Aerospike engine development. Historically, aerospike engines have been viewed as complex and difficult to develop due to their cooling challenges and manufacturing difficulties. The fact that Polaris has made significant progress in this technology, achieving in-flight ignition with their AS1 engine, is counterintuitive. It suggests that advancements in materials and cooling technologies may be overcoming barriers that previously hindered the adoption of aerospike engines in mainstream aerospace applications. This challenges the long-held belief that certain technologies are too complex or impractical for use in operational vehicles. 4. The role of startups in national defense. The involvement of a relatively young startup like Polaris Spaceplanes in a significant national defense contract is counterintuitive in a space traditionally dominated by established aerospace giants. It suggests a shift in the defense procurement landscape where innovative startups can rapidly develop and prototype advanced technologies, potentially outpacing larger, more bureaucratic organizations. This trend could lead to a more dynamic and competitive environment in defense contracting, thereby fostering innovation in ways that were previously thought to be the domain of large corporations. 5. Geopolitical context and defense spending. The timing of this contract in light of increasing geopolitical tensions in Europe underscores a counterintuitive relationship between technological innovation and military readiness. While many might assume that increased defense spending simply translates to more conventional military assets, this contract signifies an investment in advanced technology and research capabilities. It reflects a strategic pivot towards enhancing national security through innovative aerospace solutions rather than merely expanding existing military hardware. 6. Technological progression and risk. The path of developing progressive prototypes like MIRA 2 and MIRA 3 culminating in the AURORA illustrates a counterintuitive approach to risk management in aerospace development. Rather than immediately committing to a full-scale vehicle, Polaris has opted for a phased approach with smaller demonstrators, allowing for learning, adaptation, and innovation along the way. This strategy contrasts sharply with the traditional model of large singular investments in finished products without iterative testing, which often leads to higher failure rates. 7. Hypersonic flight research versus immediate military application. The designation of the AURORA as a hypersonic testbed raises questions about the immediate necessity of hypersonic capabilities. While hypersonic technology is often associated with military applications, its primary role in this context is as a research platform. This emphasizes the importance of understanding and mastering advanced flight technologies before they are integrated into military strategies, suggesting a more measured and research-oriented approach to defense technology development. In conclusion, the contract awarded to Polaris Spaceplanes encapsulates a range of counterintuitive insights into the evolving landscape of aerospace engineering, particularly concerning the intersection of military needs, technological advancement, and innovative approaches to defense procurement. The project not only aims to enhance Germany's aerospace capabilities but also exemplifies a shift towards more versatile, efficient, and research-oriented solutions in the defense sector. The report concerning Polaris Spaceplanes and its recent contract with Germany's defense procurement agency BAAINBw to design a reusable hypersonic research vehicle contains several noteworthy details that may be overlooked by a casual reader. Here are some of the significant aspects that merit closer examination along with explanations of their importance. 1. Historical context of aerospike engines. The MIRA series of prototypes developed by Polaris Spaceplanes incorporates a linear aerospike rocket engine, a technology that has been historically challenging due to cooling difficulties and complex manufacturing processes. The importance of this detail lies in the fact that if Polaris successfully addresses these engineering challenges, it could pave the way for a new generation of more efficient rocket engines. Aerospike engines adapt to varying atmospheric pressures, potentially offering greater efficiency than conventional rocket engines. This advancement could significantly impact the aerospace industry by enabling more cost-effective and reliable access to space. 2. Geopolitical implications. The announcement comes in a context where Germany is re-evaluating its defense spending amid increasing geopolitical tensions in Europe. This contract signals a strategic pivot not only for the German military but also for the European defense landscape. With calls for NATO to adapt and a need for enhanced European defense capabilities, the development of such hypersonic technologies positions Germany as a key player in strengthening its military readiness and technological prowess. It reflects a broader trend where nations are investing in advanced aerospace technologies as deterrents against potential threats. 3. Dual-use technology. The vehicle's capabilities are not limited to defense applications, it is also designed to serve as a testbed for scientific research. This dual-use nature of the technology could facilitate a broader range of applications, including scientific experiments in hypersonic flight aerodynamics and propulsion technologies. The significance of this lies in the potential for collaboration between military and civilian sectors, fostering innovation that can benefit both realms. Furthermore, the ability to launch small satellites expands the commercial viability of the project, tapping into the growing demand for satellite deployment services. 4. Design and reusability. The proposed design of the AURORA spaceplane as a two-stage, fully reusable system is a critical aspect that may be overlooked. Reusability is a key trend in modern aerospace engineering, as seen with SpaceX and other companies. By enabling repeated launches from conventional runways, AURORA aims to reduce the cost per launch and increase operational flexibility. This aspect suggests a shift in thinking about how access to space can be democratized, making it more accessible for various applications beyond traditional military uses. 5. Funding and development trajectory. While the current contract focuses on the design phase, it includes provisions for future manufacturing and flight testing. This indicates a long-term vision for the project, suggesting that Polaris has the backing and confidence of the German government to proceed beyond just conceptual phases. The previous funding and success in testing the AS1 engine provide a solid foundation for this ambitious project. This trajectory highlights the importance of sustained investment in aerospace startups, which can lead to significant technological breakthroughs. 6. Market positioning. POLARIS Spaceplanes is positioned as a spin-off from the German Aerospace Center DLR, indicating a strong foundation in research and technological expertise. This relationship may enhance the startup's credibility and provide access to a wealth of resources and knowledge that can accelerate development. The significance of this positioning cannot be underestimated, as it suggests that Polaris is not just another startup but one with the potential to leverage existing research and innovation in aerospace. 7. Impact on the European aerospace ecosystem. The development of the AURORA spaceplane could stimulate the European aerospace sector, which has historically lagged behind the United States in hypersonic technologies. By advancing its capabilities in this field, Germany and Polaris could inspire other European countries to invest in similar technologies, potentially leading to a collaborative European effort in aerospace innovation. This could also encourage a more competitive global landscape, prompting other nations to hasten their own advancements in hypersonic and reusable launch systems. 8. Timeframe for development. The report mentions a 3-year timeline for the design and development of the AURORA spaceplane. This ambitious timeframe reflects the urgency and priority placed on hypersonic technologies within the context of national defense. The significance here is twofold. It illustrates the rapid pace at which military technologies are evolving and the increasing pressure on aerospace companies to deliver innovative solutions swiftly in a competitive global environment. Conclusion. The POLARIS Spaceplanes contract for developing a reusable hypersonic research vehicle is a multifaceted initiative with implications that extend beyond mere technological advancement. By recognizing the significance of aerospike engines, geopolitical considerations, dual-use technology, reusability, funding trajectories, market positioning, impacts on the European aerospace ecosystem, and the ambitious development timeline, stakeholders can gain a deeper understanding of the transformative potential of this project. Each of these elements plays a crucial role in shaping the future of aerospace engineering, national defense strategies, and the commercial space landscape, making them essential points of focus in discussions surrounding the contract. 1. Contract significance and objectives. POLARIS Spaceplanes has secured a pivotal contract from Germany's BAAINBw to design a reusable hypersonic research vehicle. This contract is critical for advancing Germany's aerospace capabilities and aligns with the country's strategic goals to enhance defense capabilities amidst rising geopolitical tensions. The AURORA vehicle is designed to serve multiple roles, including acting as a testbed for hypersonic flight research and a small satellite launcher, marking a significant step in Germany's military modernization efforts. 2. Technological innovations. The development of the AURORA vehicle emphasizes advanced propulsion technologies, particularly the use of a linear aerospike rocket engine. This engine, which has been historically challenging to engineer, allows for efficient performance across varying altitudes and speeds. Polaris's successful test firing of the AS-1 engine and its planned integration into the AURORA vehicle represent a major breakthrough in overcoming previous limitations of aerospike technology, thereby potentially revolutionizing hypersonic flight. 3. Testing and development progress. Polaris has demonstrated a clear trajectory of development through its previous prototypes MIRA 2 and MIRA 3, which have completed over 100 successful test flights. This iterative testing approach not only validates the technological concepts underpinning the AURORA project but also instills confidence in stakeholders regarding the startup's ability to meet ambitious timelines and performance objectives. Future phases of the project include provisions for manufacturing and flight testing, indicating a structured pathway from design to operational capability. For strategic context and implications for European defense, the initiative by Polaris is situated within a broader context of increasing military spending and modernization within Europe, particularly in response to changing security dynamics. The AURORA project reflects a proactive approach by Germany to bolster its defense capabilities through innovative aerospace solutions. As European nations reassess their defense postures, the success of such projects could influence collaborative efforts in defense technology and contribute to a more robust European security framework, potentially impacting NATO dynamics as well. Here are three famous historical cases similar to the recent development involving Polaris Spaceplanes and its contract for a reusable hypersonic transport system. 1. NASA's Space Shuttle Program 1972 to 2011. The Space Shuttle program was a significant milestone in reusable spacecraft technology. It was designed to carry astronauts and cargo to and from low Earth orbit and included a reusable orbiter and solid rocket boosters. The shuttle's first flight occurred in 1981 and it operated until 2011. The program demonstrated the feasibility of reusable spacecraft, significantly reducing the cost of access to space, similar to Polaris's goal of creating a reusable hypersonic vehicle. The shuttle also faced engineering challenges, particularly with the thermal protection system and engine reliability. Paralleling the hurdles Polaris faces with its aerospike engine technology. 2. The X-15 rocket plane 1959 to 1968. The X-15 program was a joint project of NASA and the U.S. Air Force to develop a rocket-powered aircraft capable of reaching the edge of space. The X-15 achieved speeds exceeding Mach 6.7 and altitudes of over 354,000 feet. It provided valuable data for the development of future space vehicles, including insights into hypersonic flight and the challenges associated with such speeds. The focus on research and development of hypersonic flight in the X-15 program closely relates to Polaris's mission to create a hypersonic research vehicle for scientific and military applications. 3. Soviet Union's Buran program 1976 to 1993. The Buran spacecraft was developed by the Soviet Union as a counterpart to the U.S. Space Shuttle. The Buran was designed to be a reusable spacecraft capable of carrying payloads into space. Its first and only flight took place in 1988, successfully completing an unmanned mission where it orbited the Earth and performed an automated landing. The Buran program faced numerous engineering challenges and was ultimately cancelled due to the collapse of the Soviet Union. The ambition behind Buran including the integration of reusable technology in aerospace parallels Polaris's objectives in creating a reusable hypersonic vehicle for multiple applications. The future outlook for Polaris Spaceplanes and its ambitious projects in the aerospace sector appears promising, especially in light of the recent contract secured from the German defense procurement agency BAAINBw. This contract, awarded on February 28, 2025 to design a reusable hypersonic research vehicle named AURORA, represents a significant leap in Germany's aerospace capabilities and aligns with the global shift towards advanced aerospace technologies. Predictions for Polaris Spaceplanes and the aerospace sector. 1. Advancement of hypersonic technologies. With the AURORA project, Polaris is set to become a leading player in the hypersonic flight domain. The focus on developing a reusable hypersonic spaceplane that can reach speeds above Mach 5 will likely catalyze advancements in propulsion technologies, particularly the linear aerospike engine, which Polaris has been successfully testing. This could lead to breakthroughs in efficiency and cost-effectiveness for both military and civilian applications. 2. Increased military and defense applications. Given the geopolitical climate in Europe and the emphasis on enhancing defense capabilities, the AURORA spaceplane is expected to serve dual purposes, as a hypersonic testbed and a potential small satellite launcher. This multifaceted approach will likely attract further investments and contracts not only from the German military but also from NATO allies looking to bolster their defense technologies. 3. Commercialization of space launch services. The ability of AURORA to operate from conventional runways and its reusable design positions it as a cost-effective alternative to traditional rocket launches. As the demand for satellite deployment continues to rise, Polaris may penetrate the commercial space launch market, offering competitive pricing and flexible launch options, which could disrupt existing aerospace launch models. 4. Collaborations and partnerships. As Polaris progresses with AURORA's development, we can anticipate increased collaboration with established aerospace entities, research institutions, and defense contractors. Such partnerships could enhance technology sharing, accelerate development timelines, and broaden the scope of applications for the spaceplane, thereby solidifying Polaris's status in the aerospace ecosystem. 5. The focus on sustainability. The development of reusable aerospace systems aligns with global sustainability goals. Polaris's emphasis on a reusable hypersonic vehicle could set a precedent for environmentally conscious aerospace engineering. As the industry faces pressure to reduce its carbon footprint, innovations in fuel efficiency and sustainable materials may become a focal point of future projects. 6. Shift in European aerospace strategy. The success of Polaris could contribute to a wider shift in European aerospace strategy, emphasizing homegrown technologies and reducing reliance on non-European suppliers. This could foster a more robust aerospace industry within Europe, leading to increased investments in research and development and a stronger collaborative framework among EU nations. 7. Technological innovation and research. The Hypersonic Research Vehicle will not only advance military applications but will also serve scientific research purposes. This dual-use capability could lead to significant innovations in aerodynamics, materials science, and propulsion technologies, benefiting various sectors beyond defense, including commercial aviation and space exploration. 8. Public and private sector support. As Polaris continues to make strides, it is likely to attract attention from both public and private sectors. Government support for defense-related projects, coupled with potential private investment in commercial applications, may provide the necessary financial backing for ambitious projects like AURORA to succeed. 9. Global competitive landscape. The advancements made by Polaris will place it in direct competition with other aerospace companies worldwide, particularly those in the US and Asia, which are also pursuing hypersonic technologies. This competition could spur further innovation and technological advancements, benefiting the entire aerospace sector. 10. Long-term vision for space exploration. The capabilities demonstrated by the AURORA spaceplane could serve as a stepping stone for future missions beyond low Earth orbit, potentially contributing to international space exploration efforts. As commercial and governmental space agencies look towards Mars and beyond, Polaris could play a pivotal role in developing the technologies required for such ambitious goals. In conclusion, Polaris Spaceplanes stands at the cusp of a transformative era in aerospace engineering. The successful development and deployment of the AURORA hypersonic spaceplane could not only elevate Germany's status in the global aerospace landscape but also drive innovations that shape the future of air and space travel. As the company embarks on this journey, its progress will be closely monitored by stakeholders across the aerospace and defense sectors, with immense potential for growth, collaboration, and impact on future technologies.